I use a lot of electric motors now in my model airplane hobbies. In free flight model airplanes, such as the Z-36, I use it in electric sailplanes and electric sport planes, and even now electric control line airplanes. And I expect to be using electric motors more in the future as battery technology improves. I drive a hybrid car which is partially electric, and hopefully someday in the future I'll be driving a car that's all electric. When a magnetic current is passed through an electric wire, it creates a magnetic field around the wire. Here you see the needle of the compass being deflected as I move the wire over the compass, carrying electric current. The magnetic force will increase even more if the wire is wrapped in a coil. The strength of the magnetic force is proportional to the number of coils. The force increases even more with an iron core in the center of those coils. An electromagnet is an important principle in the operation of an electric motor. Permanent magnets do not need electricity to produce magnetism. Like an electromagnet, there is a north and a south pole. Opposite poles will attract, while similar poles will oppose each other in force. These two types of forces are combined in this simple two-pole electric motor. Oh no, looks like I've had a fail. I guess I have a screw loose in my motor. I'll take this opportunity to point out some parts of the motor. The shaft is the armature, and the part where the wire is wrapped, those are known as the poles of the motor. It's a two-pole motor. And in the front, the shiny part is the commutator, where the brushes rub up against. And you'll notice the gap in between. As I put the motor back together again and start it up, you're going to notice as I spin it around the brushes that move against the commutator that switch the electricity between the poles. These brushes are made out of metal, but often carbon is used. You might want to look that up and see why. Now I'm going to remove the permanent magnets and switch around the polarity. Do you know what's going to happen next when I start up the motor again? The motor rotates in the opposite direction. On my Ideas Inspire website, you'll find instructions for building a very simple electric motor. Now, this isn't a true electric motor that switches the polarity on the poles, but it just turns on and off the electricity to a coil of wire as it spins around. This is a good student project, but it takes some accuracy and properly coiling the wire and sanding off the insulation on the wire in just the right spot. This is a 3-pole motor which should be self-starting without you having to give it a little push to get it started. Darcy White, the guy that designed the Squirrel model airplane, also designed and sold a almost all wood motor kit called the Dinky motor. Now it has no iron core, but that is a fairly common thing. I installed a coreless motor in an AMA Alpha, a model that is normally powered by a wound rubber band. It worked really well. The kit is available at a reasonable price from the Academy of Model Aeronautics. It comes with the rubber motor and even a winder, but I decided to use electric motor and then a cheap motor timer on mine. The motors are like the kind you'd find in a quadcopter. Here is a 7mm motor that was taken apart. You can see the outside shell and then the windings without an iron core. This motor uses a magnetic switch, which is the switch that turns it on and off in the presence of magnetism above it. Here is a close-up of the magnetic switch. I really made a mess of this motor by using CA glue and then spraying on accelerator. That's what all the white areas are. If you look really closely at the magnetic switch, I think you can see some sparks. The problem with this type of motor is if the sparking is too great, it will tend to weld together the magnetic switch and then it won't function. This is my demonstration of a brushless motor. Brushless motors have no brushes but do the switching of the electricity by electronic means. The electronic component is known as an ESC, which stands for Electronic Speed Control. By means of electronics, it can sense where the position of the motor and the magnets and the stator are and able to give it the proper sequence of electrical impulses. When you connect the battery, it goes through a startup procedure where you can see the light flashing and you hear a series of beeps. And after it goes through this, then the motor will start, and only then. This particular motor is what is known as an outrunner. The outside of the motor spins, and that's where the magnets are, and the inside has the coils. Brushless motors are normally more efficient than brush motors. Can you think of some reasons why? Well, thanks for watching.